Okay, I'm at a customer's house here, and we found out we had 5 amps on the water pipe, a lot of high magnetic field, about 3 to 10 milligauss throughout the house, and some places as much as 20 milligauss. And we looked at the panel, it needs an upgrade. So Eric, go ahead and tell me what's going on here.
We're upgrading the service overhead from 150 amps to 200 amps. We're moving the main disconnect outside. So our first point of contact between ground and neutral is going to be outside the house, outside the foundation, and not inside. Right now it's a knob service. It's just SEU cable going up the house. We're going to put it in a piece of 2-inch rigid, use a hard mass that'll shield the electric fields.
Oh wow! So we got the piece down at the bottom here to shield the electrical fields, and
right.
maybe be lucky with some magnetic fields a little bit possibly, but we'll see.
I think so.
A little bit there.
The cable you see in the bottom is
so yeah, get a little closer here. You can tell me what's going on inside here. So you have your two phases here, I guess, right?
Yeah, this cable here is temporary.
Okay.
This is because we're not doing the panel today. We're repowering the existing panel, so we have 2 phases and a neutral. But when we come back in a couple of days, we're going to change this out to a 3-wire with a ground. So it'll have it'll have 2 hot legs, it'll have an insulated neutral, and then it will have the bare conductor for the ground. So that's going to be temporary. In a minute, we're going to pull this down. We're going to disconnect in the house. I'll disconnect the utility up there. We're going to raise the mast. I'll reconnect. I'll power the meter socket. We'll get the panel re-energized. But what we've already done is we've already driven 1 5/8 ground rod, 8 foot in the ground.
So is that a 1/0?
No, that ground rod is a 5/8 diameter.
Okay.
But it's going to be bonded with a number 4 bare copper laying on the ground right
Okay,
there.
awesome. Well, yeah, better than the number 6.
And we're going to add a second ground rod. So
okay, the second ground rod. Okay, so it's in series. It's in
series.
In series. Okay.
And it'll be one continuous grounding electrode conductor.
Okay.
It's called.
Yeah.
It'll come out of the ground bar where it'll bond this cabinet, but it's going to hit 2 ground rods. The goal being, now code only requires 1.
Right.
And but we're going to use 2 because what we're trying to do, the current that passes underground, we're trying to give it a very low resistance, attractive path back to the source. So if 2 ground rods with a big thick copper conductor is going to be very low resistance. The current, it's going to send more
basically, as the dirty power we know rides on that 6 side comes into the two phases. Okay, now hopefully it won't travel into the house. It'll come right down to the ground rods because less resistance.
Yeah, this service here was not grounded. The existing service is not grounded. So the only way back to the source is through the neutral, which is undersized. And I'm sure those connections up there are a bit corroded.
Yeah, we might get a little loose.
They're high resistance.
High resistance, yeah.
So you're going to have less current on that path. We're going to clean all that up.
Yeah. So that's good, especially since we have another route to the we have the substation over there.
The service drop comes off the house and hits that pole.
Yeah, the pole, and get it back to the substation.
Transformer, that canister on the pole is your transformer.
Yeah, I was saying out earlier that I wouldn't be surprised a lot of this current was finding. I wonder if this house was a higher, easier path for whatever reason to get back to that substation from other houses, or other houses in here they might have the 3 to 5 amps as well. I'd be interesting to wish I kind of knew that.
This is kind of the narrow end of the funnel, as the current is all trying to go back to the source. You know, if it's being funneled back to its source, we're kind of in the narrow end. Kind of at the stem. So what we're trying to do is corral the current.
Yeah.
And give it one.
Because we know it's all the whole neighborhood's connected to all the same water piping system, so they could go in through either any house here, wherever wants to go. And
water pipe.
Yeah, I bet you have a water pipes between 1 to 5 amps or even higher in some cases as well. Well, what an exciting day here. I know the homeowners are super excited about this. They have some things going on that I know exactly how they feel. I went through some really tough times with electromagnetic fields, and I know that when we do this, the pressure is going to be off the body. Already they're seeing some great results by cutting the water pipe, but now we have less pressure, less voltage, less.
And we have another issue.
Okay.
We have another issue. So the siding on this house is metal siding.
Oh, grounded.
And it's bonded.
It's bonded. Okay.
Yeah, they drove a ground rod for it.
Right.
So as the current passes through the ground and sees that ground rod, it's going to bring current up to the siding.
Yeah.
We're going to bond all that right here.
Okay, good.
So it's not going to have different points.
So I guess the homeowner thinking about bonding might keep it, if it's a little block, might possibly be blocked the radiation of the component, then maybe go travel on the side and go down, but then we still have a route going back up.
Yes.
So that's why it's
objectionable current.
Objectionable current. Another code violation, actually, but it's what we call an accidental trespassing. But it just happens with the way this thing's it's wired here.
And the idea being is that if should the siding ever become energized, if a hot wire comes into contact with it, the current will do.
Yeah, where was it bonded? Is it up there now?
I haven't seen it yet. Andy was telling me about it.
Okay,
It's
all
on
right.
the other side of the house.
Yeah, but I understand why he rounded it though.
Yeah.
Get that, but then we still have a path in or out.
Right.
So we're gonna reduce that by.
We're gonna bond it. Everything's gonna be bonded here.
Bonded there.
As it should
Okay.
be.
All right. Well, I'm excited about seeing this is all completed here. I'm looking to get the results of the after of the with Pico and oscilloscope,
yeah,
and
we're gonna do the magnetic field test, and we're gonna test the resistance to ground.
Yeah.
Like with 1 ground rod, with 2 ground rods.
Okay.
And right now I got a number 4 bare copper.
Okay.
For the grounding electrode conductor, but I may.
Yeah, so we have a more surface area for radio waves too to get out of the house as well.
The less resistance you have, the more attractive the path is for the current, and that's what we're trying to do, is attract it to one path.
Well, folks, Eric's an expert in this field. He's been doing this a long, long time. He's one of the most teachable electricians I've ever spoke with. That's why he does all my jobs now. And we've kind of teamed up here, and he does this full time. You can call Eric as well. I'm more than happy to give his number to do all electrical work. And then obviously he can do some building biology work. He knows what he's doing. And I have some additional equipment, but he can do it all on his own. Thank you so much, and have a great day.